Here welcome to you with another class here. In this class, students, I am going to explain another problem based on the cumulative triangle and basic proportionality theorem (BPT) Thales theorem. Okay, so let's see. This question you will find frequently and used to coming in the CBSE paper, and very simple problem based on the basic proportionality theorem. Okay, let's start. You see, and here in this question given, students, here you see, you are able to see now here ABCD is a trapezium, AD parallel to BC. Okay, and again is given EF parallel to BC. Then we have to prove that AE upon BE is equal to DF upon CF. Is it clear? Okay, let's see this question. And it is given that ABCD is a trapezium. ABCD is a trapezium. Where AD parallel to BC, one of the opposite side, one pair of opposite sides is parallel. Again, it is given the EA parallel to BC. EA parallel to BC. Okay, and you have to prove that AE upon BE is equal to DF upon CF. Is it clear? Understand? So let us find. Okay. Let us see now. So here, what is given here? ABCD is a trapezium. Where AD parallel to BC. Okay, AD parallel to BC, and also given EA parallel to BC, and BC parallel to also AD. So that implies EF also parallel to AD. Yes or no? Okay, and we have to prove that AE upon BE is equal to DF upon CF. Is it clear? Okay. And for that we have to do a simple construction. Is that what is the construction? The construction is that here AC join, AC join, AC join, AC join, which intersect EF at the point, suppose M, at the point M. Okay, here AC join. Okay, this is the construction. Here AC is join which intersect EF at the point M. At the point M. Okay? Understand? At the point M. Okay? So this is the construction for these questions. Okay? Let's see now. Now let's see. Let us prove. Okay. Now you see in triangle already it is given that AD parallel to BC and BC parallel to EF. So that implies AD also parallel to EF. Okay, if AD parallel to EF, that implies, you see now, If AD parallel to EF, then AD also parallel to EF. And also FM also parallel to AD. FM also parallel to AD. Okay. Now see carefully. In triangle ABC, EM parallel to BC, EM parallel to BC. Okay. In the triangle ABC, look at here. In this triangle ABC and EM parallel to BC. Why? Because EM is also parallel to BC. Okay, it is given. Right? So that implies I can apply AE upon BC. AE upon BE is equal to AM upon CM. AM upon CM. This is the basic proportional theorem. Right? Understand? Okay. And similarly by VPT, basic proportionality theorem. Similarly again you see here in the triangle ACD, here FM also parallel to AD because EA parallel to AD. Okay, so FM also parallel to AD, right? Okay, and now again in triangle ACD, now see MF parallel to AD, MF parallel to AD. Why? Because EF is parallel to AD. That implies, so we can write AM upon CM can be equal to DF upon CF. Yes or no? Since FM in the triangle ACD and MF parallel to AD, so AM divided by CM is equal to DF divided by CM. Okay, according to VPT. So this question example second point you got by VPT theorem. Okay, so you will see now from the equation 1 and 2, AE upon AE upon BE is equal to AM upon CM. Again, AM upon CM is equal to DF upon CF. So from the equation 1 and 2 can equate that AE upon what is BE. In the equation 1 we are getting what? AM upon CM, and again AM upon CM. In the equation 2 we are getting DF upon CF. So it is clearly we are getting that. Okay, so AM upon BE, AE upon BE, AE upon BE, this is equal to DF upon CF. DF upon CF. This is what we have to prove it. Okay, if you understand, this is what we have to prove. Okay, so is it clear? Okay, let's practice, students, this one. Let us practice it. Okay, very simple problem, easy problem, and it is also in your NCERT book, and you can practice it. Okay, thank you. Students, in this class I am going to discuss a problem based on the similarity of triangle and based on the concept of basic proportionality theorem and the corollary. Okay, and here in this question, okay, it is given that let's see, in the triangle ABC, it is given that MX parallel to AB and NX parallel to AC or XN parallel to AC, it is given, and prove that TX square is equal to TV multiplied DC, TV into DC. Okay, understand? You see now in the triangle ABC, you see MX parallel to AB and XN parallel to AC. Okay, and you will prove that TX square is equal to TV into DC. Another thing you see here the MN has been extended. MN is extended which intersect the produced CB at the point M, at the point D. Okay, understand? So let's see now. So okay, let's see what is given in the question. So in triangle ABC, Okay, and you see the xn parallel to VC, parallel to xn parallel to AC, not VC, xn parallel to AC. Okay, and mx here given mx parallel to, here you see mx parallel to AB. Okay, and to prove tx square is equal to tv into tc, right? tv into tc. Let's prove. You see now, look at here in the, okay, and you see one of the triangle, you will see in the triangle. Which triangle you see? Yes, in the triangle, look at here in the triangle TXM, this triangle, are you looking? TXM triangle. You see the AB parallel to MX, it means the MX, okay, MX also parallel to BN, because BN is a part of AB. Is it right? So in the triangle, TXM, in triangle TMA, you see now the BN parallel to MX, BN parallel to MX. Why? Because since AB parallel to MX, that implies, and AB parallel to MX and BN is a part of MX. So that's why BN parallel to, that implies BN parallel to MX, because BN is a part of AB, right? So you can use this if the triangle, okay, if BN parallel to MX, now you see the TB divided by TX is equal to TN divided by TM. Can you write or not? According to corollary of the BPT, corollary of the basic proportionality theorem, so TB divided by TX is equal to TN divided by TM. This is by corollary of BPT. Corollary of BPT, all of you know. So this is point number 1. Okay, understand? Okay, and again you see in the triangle, another triangle are you seeing here? TMC triangle. In this TMC triangle, look at here, NX parallel to AC, it means NX parallel to CM. Yes or no? So in triangle, again in triangle, okay, again in triangle TMC, okay, NX parallel to CM, because CM is a part of AC, NX parallel to AC, NX parallel to AC, so NX parallel to CM, okay, so that implies we are getting that, if, understand, so what you are getting then, TX by TC, same process, TX by TC, if this triangle TCM and NX parallel to CM, then TX divided by TC is equal to TN divided by TM. Right? And that is equal to TN divided by TM. This is also corollary of the BPT. And all of you know in the previous class we discussed. So this is the point number 2. So the point 1 we got, you look at here, that TB by TX is equal to TN by TM, and you got here TX by TC, you're getting what? TN by TM. Okay, so from this you see, from this we see what you get. Let us compare the equation 1 and 2. Now you see now TB by Tx. This is TB by Tx. TB by Tx is equal to Tn upon Tm, and Tn upon Tm, the equation 2 is equal to Tx by Tc. Yes or no? So you can compare. So Tb upon Tx is equal to Tx upon Tc. Yes or no? So that implies if the Tx and Tx is Tx square is equal to Tb into Tc. Tc will be transposed. This will be Tb into Tc. This is how we prove the required what we want to prove. Okay. This is, so you have to prove that Tx square is equal to Tb into Tc. Thus we get the value result. This is the required expression. Thus this is how we can prove the given concept. Okay. So let's see this. Let us practice it. Okay. And see you next. Okay. Once again, bye. Thank you. Okay. Welcome back to my another class here. And here I am going to discuss a basic deductive problem based on the similarity of triangles. Okay. And this is another interesting question I am going to discuss for you. So all of you look at carefully. Okay. And here you can clearly see the figures. The diagram is given that ABCD is a parallelogram. Okay. ABCD is a parallelogram. And here the DP is extended up to L, which intersect the produce AB at the point L. Okay. DP is extended up to L, which intersect the produce AB at the point L. We have to prove that dP upon PL is equal to DC upon BL. DC upon BL. Okay. Understand? Okay. And let's see now. And what is given? Let us write. What is given here? The given ABCD is a parallelogram. ABCD is a parallelogram. Okay. ABCD is a parallelogram. And here DP is produced, is extended which intersect AB produced at the point L, to prove number one, first bit, dP divided by PL is equal to DC divided by BL. And second bit, we have to prove that DL by DP is equal to L upon DC. L upon DC. Right? It's okay, all of you? Is it clear? Okay, let us prove. Okay, students, you see now, we are getting now in a triangle AL, you see ALD triangle, but DAL triangle. Are you seeing? And you see now DP parallel to AD, because AD parallel to BC, so AD parallel to BP. Okay, you can use the, so now in triangle DAL, look at here, AD parallel to BP. Why? Because BP is a part of BC and BC parallel to AD. That is why AD parallel to BC, so BP must be parallel to AD. Okay. Now you can write, what you can write here? Now you can write dP divided by PL is equal to AB divided by BL according to the basic proportionality theorem. We can write, so dP upon PL. Yes or no? DP upon PL is equal to AB upon BL. AB upon BL by BPT. Basic proportional theorem. This is point 1. Okay. Is it clear? Understand? Okay. Again, you can rewrite this one. That implies dP upon PL is equal to. Now you see, we can write the AB. Look at here. AB equal to CD. Opposite sides are equal. AB equal to CD. So in place of AB, I can write CD. Right? So in place of AB, I can write CD. So CD upon BL. This is what we got, and this is the point 1 we got. First point already got. Okay. dP by PL is equal to dC upon BL. First we got. It's okay, students. Okay. Now second we have proved that the dL by dP. What is that? The dL by dP is equal to AL by dC. Yes or no? Okay, let's see this one. Okay, note down. Understood this one? Once again, see the second part. You have to do it. Okay, in the first part, what do you get? In the first part, you got from the first part, second bit. Second part is that prove that to prove dL upon dP is equal to AL upon dC. Okay? Since we already got dP by the dL by dP is equal to AL by dC. We already know dP upon dPL is equal to dC upon BL. From the first part we got. From the first part we already got dP upon PL is equal to dC upon BL. So let us find the reciprocal. dP by PL will be PL upon dP. Reciprocal, do it reciprocal. Then dC by BL is equal to BL upon dC. BL upon dC. So that implies PL upon dP is equal to BL. Okay, students, you see now DC is equal to AB. So DC is equal to AB. So in place of DC, again you write AB. Why? Since DC is equal to AB, opposite sides of the parallelograms are equal. It is given. Since ABCD is a parallelogram, so DC is equal to AB. Again you can write. Okay. Now let's see. See here. Now let's see. You add 1 on both sides. Okay. You see now PL by dP plus 1, add 1 on both sides. BL upon AB plus 1, right? Is it clear? So that implies, if you get this is dP PL plus dP is equal to BL plus AB upon AB, right? Okay, understand? Is it clear? Now let's see PL plus dP. Now you see the PL plus dP. Here you see the PL upon dP, which is dl. The length is dl by dP. dl by dP is equal to BL plus AB. You see now BL plus AB. The length is total length is AL. Yes or no? So AL by AB. That implies dl upon dP is equal to AL upon AB. Again you can write AB is equal to CD. We can write AB is equal to CD. Again in place of AB we can write CD. Okay, and this is the second part I think. Thus we got the second bit. This is how. Okay, this is what we are going to do it. And the second part we got. Okay, understand? It's fine. Okay, try to follow. Okay, and practice it for your betterment, and also see the similar kind of problem. Okay, the problem solving and deductive approach is the most important factor in the geometry. Okay, you have to try the how many different type of property, geometrical properties you can prove. Okay, understand? Thank you once again. Here with another class for you, and here I am going to discuss with another interesting question problem for you based on the basic proportionality theorem. Okay, similarity of triangle of the standard 10. This question also used to come frequently in your different kind of exam, also in the CBSE paper. I hope you will see it in a careful manner. Okay, and also you will follow it. Let's see. The problem is that it is a figure related problem, and in this diagram it is given that clearly the DE parallel to AC. Okay, DE parallel to AC, and you see the DC parallel to AP given. This is the thing given in the given figure, and we have to prove that BE upon EC is equal to BC upon CP. Okay, understand? Now let's see what is given. Now given that in the triangle is given DE parallel to AC. In the given figure, DE parallel to AC. Again given DC parallel to AP. Yes or no? Okay, and to prove BE upon CE is equal to BC upon CP. DC upon CP. Right? It's clear? Okay. Now let's check it. Let us prove. Okay, students. Now let's see. Let's see in the triangle ABC. And now you see DC parallel to AC. In the triangle given in triangle ABC and DE parallel to AC. So we can use BE upon CE. You see now DE parallel to AC. So BE upon EC is equal to BD upon AD is equal to BD upon BD upon AD by BPT by BPT. Is it clear? Understand? So this is the first one we got. Right? Okay. And similarly again you see in the triangle ABP triangle. Are you looking here? In the triangle ABP, again you see the DC parallel to AP. So you can write BC upon CP is equal to BD upon AD. Can you write or not? Again in triangle ABP. Yes or no? And in this triangle, let us see now the DC parallel to AP. Okay, DC parallel to AP. So we can write what? What you can write? DC parallel to AP. So BC upon CP is equal to BD upon AD by BPT. Okay. So BC upon CP is equal to BD upon DA or AD. This is also BPT. Basic proportionality theorem. This is point number 2. Now you are able to see now from the equation 1 and 2. Okay. So what are you seeing here? The BE upon CE is equal to BD upon AD. And in the second point we got BC upon CE is equal to BD upon AD. So you can write BE upon CE is equal to BC upon CF. BC upon CF. Okay. BC upon CP. This I think in the triangle. Look at once again in the triangle ABP. You see DC parallel to AP. So BC upon CP. BC upon CP. This is not F. Okay, student. This is not F. This is CP. This is CP, and this must be CP. Okay. Understand? So finally we got. Thus we proved that in the given diagram, this is the required simple problem, simple deductive problem we got. Okay. Is it clear, students, all of you? So let's practice this one. Okay. And also try to solve the similar kind of problem. Thank you. So here is another class for you. And in this class, students, I am going to explain the another problem based on the concept of simulated triangles. And in this questions here, it is given that, and here in the triangle ABC, look at carefully, DE parallel to BC given. Okay, in the triangle ABC, DE parallel to BC. In the triangle ABC, look at here, ABC is a triangle and DE parallel to BC. Again, DC join and DC parallel to AP. DC parallel to AP. Okay, this is given. And you have to prove that AD square is equal to AB into AF. AB into AF. Okay, AB square, here AD square is equal to AB into AF. Okay, understand? So let's write this question. What is given in this question? Clearly it is understood. Same thing I am writing here. DE parallel to BC in the triangle ABC. DC parallel BE parallel to BC given. And another given what? FE parallel to DC. Yes or no? And to prove that AD square is equal to AB into F. AB into F. Okay? AB into F. Right? Let's prove. Understand? Now let's see, students. It is clearly understood. ABC is a triangle. In triangle ABC, DE parallel to BC. It is given that. Okay. Write down in triangle ABC, DE parallel to BC. DE parallel to BC. DE parallel to BC. Okay. Understand? So since D parallel to BC, we can use AB upon AD. Can I write? AB upon AD. Are you looking here? Here this is AB and this is AD. AB upon AD. Similarly, AC upon AE. This is the corollary of the basic proportional theorem. AB upon AD is equal to AC upon AE. It's okay? This is the corollary of BPT. Okay, this is the point 1 we are getting. It's clear? Okay. Similarly, another triangle you see in the triangle ATC. Here see ATC is a triangle, and in this triangle, ATC triangle, you see the FE parallel to DC is also given. Okay. Again in triangle ADC. Okay, and what is given? FE parallel to DC, right? Okay, and similarly, can use AD upon AF. AD upon AF. Are you looking here? What is AD? Here AD upon AF. Can we written what? AC upon AE. Yes or no? Yes, right? AD upon AF is equal to AC upon AE. AC upon AE, and this is also the corollary of the basic proportional theorem. This is point number 2, right? Okay, are you looking the point 1 and point 2? Are you getting now? AB upon AD is equal to AC upon AE. Is it clear? Again you see AD upon AF is equal to AC upon AE, right? So now from the equation 1 and 2 we are getting now AB upon AD is equal to AC upon AE. Yes or no? From the equation 1, and AD upon AC upon AE is also equal to AD upon AF in the equation 2. Okay, AD upon AF is equal to AC upon AE, and AC upon AF can be written AD upon AF. Okay, So AB upon AD is equal to AC upon A is equal to AD upon A. So that implies, so AB upon AD is equal to, understand, you can write AD upon AF, right? Okay, understand? Is it clear? Now you can transpose AD and AD is what? AD square, and you can multiply AB into AF, right? So we can, you see now, that implies AD multiplied AD square is equal to AB into AF. Is it clear? Okay. So this is the what we are going to prove. Okay. And this is also another simple problem, and also, and you are using here how you can use the BPT theorem and corollary of the BPT theorem in solving and in while we are proving the various different kind of geometrical statement. Okay, and deductive problem we can prove, and this also problem used to come in the various different kind of exam also, and also you will try. Okay, this. Okay, and also you will try the similar kind of problem. Thank you. Okay, see you next. Bye.